My name is Joel Douglas. I'm a member of the UCONN Engineering Academy of Distinguished Engineers, and I'm also the CTO of E.Gen. We're an energy harvesting company. We created a energy harvesting machine which uses slow-moving water to create electricity. I joined Electric Boat in United Nuclear in 1977 after I graduated. And in 1988, I got lucky and I went to California, where I went to work for COMAG, which was the developer of the thin film disc. While working at COMAG, I decided that, I really want to start my own company. I thought this would be great. But it was clear to me that I would never be able to start a thin film disc company, which I loved. I loved making thin film discs because it would take about $1 billion at the time to do that. So I sat around and I tried to figure out where could I go where I could start a business in the garage. And this was really pre-internet time. And so it was hard to start a technology company in a garage. But I did come across an idea. I said medical devices. And I floated the idea past some of my coworkers and the founder of COMAG, and we said, yep, that's it. So I went down the street and joined LifeScan. And I learned the medical device business. And the woman I was working with at the time, she said, time for us to start our own company, and that's what we did. We started Mercury Diagnostics, which eventually became Amira Medical. Amira Medical was sold in 2001, and I started Sterling Medivations, however, before that in 1999. And that was also sold in 2001. Sterling was a great company, and I worked in there till 2004 with the acquirers. And then I started Mystic MD in 2004, and that was a manufacturer of conductive inks. Then I started E.Gen in 2006, and you'll notice there's some overlap here because Mystic MD is still in existence, and E.Gen is in existence. And I sold the companies in 2008, and I now work for the acquirers. Amira was a great company. We developed the alternate site blood glucose monitor. It's called Atlas. This device combined both the lancing system and the testing system into one device. And when we were looking for money, we had developed a product, and the investors said, it's a great product, but I'd invest in you if you had a minimally invasive or non-invasive product. And I said, well, what do you mean by that? That it doesn't hurt. So my partner and I go back to our office and we sit down and we hatch an idea. We're going to take blood off your arm. And we knew that if we took blood off your arm or your thigh, that it wouldn't hurt. It would be, you barely feel it. And so we set up an idea, we tested the idea, and we wrote a patent, and we go back and we say, hey, what if we did this? And they said, we'll invest in you. And so we got the investment, and that's where the real work started, because our idea didn't work very well. Okay, yes, we could get blood, but B, it wasn't enough for doing a test. And we're all sitting around a conference room, everyone is depressed, we've been working on this for months, it hasn't worked at all, it's been really negative, we're spending a lot of money a month, burning through our cash that we had raised, and everyone's depressed. And I'm sitting at the conference table, and everyone got up to have coffee, and I'm sitting there and I'm looking around and I lance my arm, and then I pick up a syringe cap and I press on it twice, and I got this large puddle of blood. Whoa, it's unbelievable. And so everyone comes in, we try it, everyone looks at it, and everyone says, yes, that's the answer. We go back to the lab and show my business partner and our chairman, and yep, that works. Wow, that's unbelievable. We need to refine it, figure out actually how to make this work. And so we do that, and we spend months going through the geometry, the pressure, the angles, the radiuses. I mean, months. Okay, come to find out after we go through this huge series of tests and battery of options, that the syringe cap is the ideal dimensions in geometry for this blood sampling extension. The company was sold to an acquirer, and what happens then is there's lots of hands in the pie, okay? And everyone has so many shares, and it gets divided up accordingly. And the key for you is to walk away with more than you started out into it, and that's a successful venture. And if you do a really good job, you'll come out pretty good. You really have to focus on development, okay? And you have to focus on what you're trying to accomplish, and you have to lay out what your objectives are and what you're trying to achieve. You also have to look at things like price points. You have to look at cost of goods. You have to look at packaging. So, it's just not, I've got this technology, and then I've developed this technology, and oh wow, everyone's going to come see it. That's probably not going to happen. So I take the holistic approach that technology is just one small segment of it. There's the marketing, the sales, how you position the product, even how much shelf space it takes up on the shelf if you're making a consumer device like we were. I think the key thing that I got out of my engineering degree more than anything else was the ability to think objectively. Okay, that really was a key point, because I graduated as a civil engineer. None of that information helped me when I was doing thin film discs. None of it helped me when I was working at United Nuclear. Okay, none of that stuff helped me develop chemistry or electronics for blood glucose meter or Lansing devices. But what they did give me the opportunity to do is look at things from basic engineering principles. And that's really important, and you really need to understand the basic engineering principles. You really need to understand mechanics of materials. You really need to understand dynamics. You really need to understand statics. You really need to have some basic electrical engineering. You really need to have these things, okay? And so what I can coach the students is that you need to take those courses, okay? And because those are going to be the background courses that you're going to need to be successful. So you're going to eventually need to have some business information. You're going to have to understand the business part. You have to also understand how things are sold into both commercial worlds and into both consumer worlds, okay, depending on where you go with your product. And so that's a big part of your skill sets that you're going to have to learn are what I call the secondary skill sets, which are the business skill sets. You have your basic engineering skill sets, then you get the business skill sets, and that will give you a more complete education. Anyone can do it. It's not that hard.